All right, guys, here is mock exam number 2. And so let's take a look at this. Here we had checking out the flu rate based on having placebo or vitamin C. So we had categorical data here, okay, with those things. Now, first question, was this an experiment or an observational study? Well, if you had read in here, then you saw that we had the random assignment of the patients to one of the two treatment groups. So therefore, it's an experiment because patients are randomly assigned to the treatment groups of vitamin C or placebo. Be specific, always context. Okay. Next question was asking just a numerical computing, and it asked, is, let's see here if I can get this correct. If a student volunteer is selected at random, okay, then from those students in the study, what's the probability that he or she contracted the flu? So that's out of all the students, then what proportion of those got the flu? So that means they were just asking for the flu overall, which was that 633 over 808. Okay, set 0.7834. All right, the next one said, but what happens if, given that, so this is conditional probability, given that a student took vitamin C, what's the probability that he or she contracted the flu? So in that case, then we're actually taking a look at this section right here. So of these patients who took vitamin C, these 403, what proportion of those got the flu? So that's a conditional upon you having vitamin C, which that's what this is here. Given that you've had vitamin C, then you could, out of all the 403 with vitamin C, those who are vitamin C and flu, 74.94%. All right. Then the next question asked, are those events, taking vitamin C and getting the flu, independent events? Well, from we formula chart and even our mock exam number 1 that, you have got to know mathematically how to check for independence. And so what we're doing is we're checking if something overall, the probability of an event overall is being changed given that, something else has happened. Okay, so we're checking those events. So in this case, what I determined was, well, the treatment, the vitamin C, was our one that is the here the treatment. That's our given that. So given that you're having vitamin C, is that then going to change the rate at which you get the flu? So I took then flu overall from part B is so flu overall is 78%, 0.34%. But given that you took vitamin C, look, you're getting flu at a lower rate, 74.94%. So the fact that you took vitamin C changed the rate at which you got the flu. So that's why the events are not independent. Okay, so you need to say that. Not independent. Elaborate. The fact that you take vitamin C makes you less likely to get the flu, and numerical support right here, 74.9% to 78.3%. All right, the next question asked you to, if we were to run a hypothesis test, it said state the hypothesis statements and the test that you would complete. So what I wanted to point out to you is that question seems simple, but there's more involved that it doesn't specifically say to include, that you need to make sure you include. And so let me explain. If you think, oh, I just need to write my null hypothesis and alternative hypothesis statements, and you do something like this, okay, then in the years past, that's been okay if you have little subscripts that are meaningful in context of this problem, but no longer. And I think that's absolutely right to have this is an incomplete answer, Because if I go write down those letters, what do those letters mean? You know, you can't just write down things and assume people know what you are referring to. So even though the problem specifically just said define the name of the test that you would run and the hypothesis statements, this part here is essential. Okay, you have to define what this problem, the parameters of this problem are, which is why when we do our phantoms, the P for parameter is always that very first thing. So let's discuss the qualities to make sure you write these parameters correctly. So P with the little subscript P is the proportion of the population of all such adults, all such ones that would volunteer like this, okay, present or future tense, who take placebo. So the ones that have that treatment and then have that certain result we're looking for. The proportion of all such adults who take a placebo and get the flu. And then P with the subscript C was the proportion of all such adults who take the vitamin C and get the flu. So this is necessary before you can then do your hypothesis statements. And this question was wondering if the vitamin C infection rate was lower than that of the placebo. Okay, now I just wrote two proportion Z test, but I'm concerned that I might not have gotten full credit for that because this technically is the two proportion Z test for the difference between two proportions. Okay. So consider, making it a complete. We know we would just go run a two proportion Z test, but it's about the difference between those two population proportions. All right. Next, question F said the p-value is 0.0096. Let me make sure that was all. Yeah. So the p-value, it gave us the p-value because this year on the test, you're probably not going to be calculating p-values. More likely, you'd be interpreting them. So the p-value is 0.0096. So since the p-value of 0.0096 is less than alpha 0.05, p-value is low, you're going to reject HO. Okay, so you need those two statements right there. Those two items here, and then stating in context what that is telling me. That's telling me then that there is evidence that the proportion of all such adults who get the flu while taking vitamin C is less than that, the proportion of all adults who get the flu while taking the placebo. So that was just the conclusion. Get your p-value, compare to alpha, make a decision, and state your conclusion. That was the last part of the phantoms. Okay? All right. And that was it. That one was pretty straightforward. I thought pretty basic, nothing crazy, just making sure you are defining all the parameters properly. All right, let's take a look at this second one. So here's a problem where we have these strawberries from a strawberry farm, and we're interested in the response that's being measured about maintaining color, discoloration due to freezing, So, so we have some examples here. We have a control group. 25 were in a control group and sealed and froze for 6 months. The other one had a preservative, put in a bag, sealed for 6 months. And then we measured the discoloration. So lower discoloration is better. Okay. All right. Questions then. The first question is the median discoloration of the control group is 7. So that's at the 50th percentile. If a random strawberry is selected from the treatment group, what's the probability that its discoloration value is less than 7? So in other words, in this section here, what proportion right here, what proportion of the treatment group had discoloration less than 7? And if you counted, there were 19 out of 25. So that was about 76% that had that. That had discoloration less than 7 in the treatment group. All right. Second question. The standard deviation of ratings for the control group is 2.141. Explain how this summarizes variability in the control group. So I'm not familiar really with that wording of that question. A lot of times, same FRQ type questions come up over and over again, and you kind of get what they're asking for. So my thought with this one is that what we're really looking for is basically your demonstration that you understand what standard deviation is in context of this problem and what it's really saying, and you're able to communicate. So I just stepped back to, what is standard deviation really telling me about this data? And standard deviation is the average distance from the mean, average distance from the mean, standard deviation. So then in context, that tells me that the average distance each strawberry's color rating is away from the average color rating is 2.14 units. I said points, but I don't, whatever units the units are. So I'm just describing, do I know how much variability that is? I don't know. I don't know what's normal, what's a bunch, what's a little. What I can say about the variability is that on average, this is how much the data is differing from the center, the average color rating. Okay. So I think that is what that was getting at, wanting to know your understanding of standard deviation and variability. All right, C. Based on the dot plots, comment on the effectiveness of the preservative in lowering the amount of discoloration in the strawberries. Okay, so here's what I found. So my thought initially is, I don't see a significant difference. In my mind, and we had this when we did our dog, the blocking dogs lab. We had a situation where we had a whole set of data with information in this vicinity and a whole set of data with information in this vicinity. There was basically no overlap. So there was a clear difference in the results. Okay. Here, my thought is, I don't see that. My thought is, look, some of these ones in the treatment are higher than some of these ones in the control. So, individually, I can't say one's better than the other. And on average, it's not probably significantly better. There's so much overlap here. Maybe I could say that this treatment group looks to be shifted down about one rating from the control. But I'm just not seeing a huge difference. So when I take a look, let me just refresh my memory on exactly what the question asked. Comment on the effectiveness of on the thing. So my comment was this: even though the discoloration in the treatment group appears to be shifted one number lower, there does not appear to be a significant difference in the discoloration rates of the treatments. That small difference we had could certainly be due to sampling variability. Just random chance of the ones I got, strawberries I got, and sampling variability. I don't feel comfortable with this picture here saying, whoa, that treatment is majorly awesome and definitely making a difference. Okay. All right. Next question is this. Research at a university calculates a 95% confidence interval, state the conditions, and confirm they have been met for this confidence interval. So with that, I just did my random independent large enough. Okay, so if we're going to do our random independent large enough, let me get that back to where we can see that good enough. So random independent large enough, then what we've got going on here, I am struggling on this for sure. Here we go. Stated that those strawberries are randomly assigned. Remember, with our random, if it's It's randomly selected or assigned. And so if it's an experiment, you better be discussing about how they were randomly assigned to the treatment groups of preservative and control. Okay. Independent, if we are just pulling them out and not replacing, we need to say they're less than 10% of the population. So I'm going to assume, because I don't know what's on a farm, but I think it's probably reasonable to say that 25 is less than 10% of all such strawberries that could take the preservative. Okay, and 25 is less than 10% of all such strawberries that would be in the control group. And remember, these are less than 10% of the population. So my description here is population. Okay. Now, don't forget also that we need to say that the strawberries in the preservative and the control group are independent of each other. There was no overlap, nobody in both of those groups, which I know it would be true because you can't take the preservative and not the preservative. Now are large enough. In this case, this is a mean problem, and our large enough is not large enough. That is not greater than or equal to 30 in neither group. However, remember that when that's the case, we go and look at the individual data, and based on these pictures here, I think both of these are sun, somewhat symmetric, unimodal, no apparent outliers or unusual features. So therefore, I think it's okay to assume that we're dealing with the approximately normal model here, sampling distribution. All right. Part E says they make a 95% confidence interval and they get this. Honestly, this interval surprises me based on the discussion we had in Part C, because if you remember, the discussion I had in Part C was I don't think the treatment is significantly better than the control. But furthermore, I don't like this question, because they didn't define for me which way we do our subtraction. I mean, I need to know. I guess in this case, they're thinking the coloration would be lower for the treatment, the preservative. So in this case, I guess they're doing the control minus the preservative, because we think the control would be a larger number. So we have positive numbers here. Anyway, so this is saying that I'm 95% confident that the difference between the coloration, oh, I guess these are not P's, these are X bars. Okay, sorry, my bad. So, I guess we would be doing for the average of the control minus the average for the, so I would have made a sampling distribution based on this, okay? But anyway, so it's about the control minus the preservative. Control would be a higher rating, okay? All right, so I'm 95%. The higher rating is between 16.16 and 2.72. So based on that, would you say there is a difference in the population means? See, so I'm attempting to estimate the difference in the population means from the control to the preservative, and I'm saying that the control is getting, I'm 95% confident that the control group's average is between 0.16 and 2.72 units higher than the preservative's average. Okay? So what does that say then? Well, in that case, then that's saying that there is, because 0 is not in that interval, because that interval is entirely above 0, then that does appear as though there is evidence of a significant difference in the average discoloration of the two treatments. Okay, so they did get averages that were significantly different to support that interval of a difference. All right, so that would be the key, is that you're talking about this interval containing 0 or not. and what that says about the average discoloration of the two treatments. All right, so there's all of that one. I guess that's all of the questions. Yep, so that was question 2 there. So that's all of those. All right, I hope that that helped you on your mock exam number 2.